Hello everybody, welcome into another lesson. So today we are going to talk about special pairs of angles. We are going to talk about complementary angles, supplementary angles, and vertical angles. And with the vertical angles, there is one new theorem that goes with it. So let's start with complementary angles. Some of you may be familiar with this already. If you've been with me since pre-algebra, or if you've had pre-algebra or any other geometry course previously, complementary angles, they're the sum of two or more angles that add up to 90 degrees. So here I have angle ABC. I have ray BD cuts through angle ABC. So together, we can say that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So if you add up the measure of angle ABD plus the measure of angle DBC, it's going to equal the measure of angle ABC, which would equal 90 degrees. Complementary angles always equal 90 degrees. They always come to a right angle, always equal 90 degrees. You can also write that angle ABD is complementary, I just abbreviate complementary to angle DBC. So angle ABD is complementary to angle DBC. If one angle is complementary to another, that means when you add the two angles together, you'll get a sum of 90 degrees. So that's complementary angles. Okay, now let's go on to supplementary angles, which probably a lot of you are also familiar with, but I do have to bring them up and talk about them. Supplementary angles. So we have supplementary angles then where the sum of two or more angles that's going to add up to 180 degrees. So if you have supplementary angles, it's the sum of two or more angles that add up to 180 degrees. So let me draw something here, okay? Let's say I'll put A here, B here, C here, then I'll put D here. All right? So angle ABC, that's a straight line. Well, ray BD intercepts angle ABC to form two angles. So together, the measure of angle ABD plus the measure of angle DBC or CBD, however you want to say it, as long as the vertex of the angle is in the middle, I'm going to say DBC, that would equal the measure of angle ABC, which in turn is going to equal 180 degrees. So the measure of angle ABD plus the measure of angle DBC, you add them together, you'll come to 180 degrees. Supplementary angles always add up to 180. Then you can also say that angle ABD is supplementary, I just abbreviate it like that, to angle DBC. So you can say angle ABD is supplementary to angle DBC. So if one angle is supplementary to another, that means if you add the two angles together, you'll get 180 degrees. So those are supplementary angles. And before we go on to vertical angles, let's do some exercises with complementary and supplementary angles. We're going to do a little bit of math and even throw in some algebra in there today a little bit. So, let's see here. We're given the measure of angle K equals 20 degrees. Step 1, find a complementary you know what, let's abbreviate it. Who wants to write all that out? A complementary angle to angle K. Okay. Then step 2, you guessed it, we're going to find a supplementary angle to angle K. Alright, so in this case, we're given the measure of K equals 20 degrees. First, we want to find a complementary angle to angle K. Well, if we want to find the complementary angle, we need to take, complementary means the sum of the two angles adds up to 90 degrees. So, to find the missing angle, you're going to take 90 degrees minus the measure of angle K, which would therefore then equal 90 degrees minus 20 degrees, which would give you 70 degrees. So the complementary angle of angle K is going to be 70 degrees. The complement to angle K is 70 degrees. Now to find the supplement of angle K, again, supplements, the missing angle plus the measure of angle K itself will add up to 180. So then you have to take 180 degrees minus the measure of angle K. That would be equal to, of course, 180 degrees minus 20 degrees, which means the supplement of angle K is going to be equal to 160 degrees. And I'm going to show you a shortcut here. There is a shortcut with this that they don't really teach in most classes because they want you to do the full out math. But this is always true in every case. If you first find the complement of an angle, the supplement of the same angle will be 90 degrees more than the complement of the angle. Because 160 is 90 more than 70. This is true in every case. The supplementary angle is always going to be 90 degrees more than the complementary angle. So there's a shortcut for you if you want to find the answers quickly. Some teachers are big on showing your work, some aren't. If you have a teacher that's not, then that shortcut's perfect for you. Okay, this particular time, measure of angle K equals 72.5 degrees. So the measure of angle K equals 72.5 degrees. So let's find the complement to angle K, which means we're going to take 90 degrees minus the measure of angle K, which means then we'll get 90 degrees minus 72.5 degrees, which should give us 17.5 degrees. So the complement of angle K is going to be 17.5 degrees. Now let's find the supplement. You'll just take that 72.5 away from 180. So it's going to be 180 degrees minus the measure of angle K, which would equal 180 degrees minus 72.5 degrees, which would then equal 107.5 degrees. So the supplement to angle K would be 107.5 degrees. All right. Now this time it's a little bit different. Measure of angle K is equal to x. So don't panic because there's a variable thrown in. Measure of angle k equals x. We don't even have a clue what angle k itself equals. It just equals a variable. No matter. To find the complement, you're just going to take 90 degrees minus the measure of angle k like we've been doing, which means you would simply get 90 minus x. You could say degrees if you want to on the outside. I wouldn't do that though. The reason is because it's going to look like you're taking the quantity of 90 minus x to the 0 power. So that's as far as we can go. This doesn't simplify any further. So the complement to angle k is going to be 90 minus x. And let me prove that to you. If I take 90 minus x, then I add that x to it, what do you know? I'll get 90 degrees. That's how you can check it. So yes, the complement would be 90 minus x. And then we'll take the supplement. The supplement is going to be equal to 180 degrees minus the measure of angle k, which therefore would be 180 minus x, which will not simplify any further. So the supplement to angle k would be 180 minus x. And if you added 180 minus x plus x, you would in fact get 180. So don't be thrown too far because there's variables now. You apply the same principle, only you're going to have variables. All right, let's see. Last exercise like this, we are going to do the measure of angle k. Measure of angle k is equal to 2y. So another variable problem. Measure of angle k equals 2y. Okay, so let's find the complement of that angle. That's still going to be 90 degrees minus the measure of angle k, which would mean that's going to be 90 degrees minus 2y, or just 90 minus 2y, we'll say, and that doesn't reduce any further. So the complement to angle k is going to be 90 minus 2y. And if you add 90 minus 2y plus 2y, you'll get 90 degrees. So that would prove that that's the complementary angle. And likewise, we'll do it with the supplementary angle. You'll take 180 degrees minus the measure of angle k, which is going to equal 180 minus 2y, and that doesn't simplify any further, so the supplement to angle k is 180 minus 2y. And if you add 180 minus 2y plus 2y, you'll get 180 degrees, proving that the two angles are complements. So that's really it for complementary and supplementary angles. I think those are pretty easy. I have no theorems for those two today. At least today. There will be theorems on them in the future, but they're not coming today. Next, we're going to talk about a type of angle called vertical angles. We have vertical angles, which I know we touched on a bit in pre-algebra, but pre-algebra has been forever ago, because we just got through Algebra 1. Pre-algebra was long before that, like since June, so it's been a while. Now, vertical angles are two angles such that, how do I want to word that? The sides of one angle are opposite, I'm going to abbreviate opposite, rays to the sides of the other angle. Alright, so vertical angles are two angles such that the sides of one angle are opposite rays to the sides of the other angle. What do I mean by that? So what does this mean? Well, let's draw some intersecting lines here. Alright, I'm going to demonstrate vertical angles here. Alright, so this would form an angle. This would form an angle. That forms an angle. That forms an angle. So now we have angles 1, 2, 3, and 4. All these are vertical angles here from the intersecting lines. So that's what vertical angles are. They intersect to form two pairs of vertical angles. So now we know. Now vertical angles, let's see. When you compare them, you're going to go diagonal. You'll go straight across. You won't do the adjacent angle next to it. You'll go straight across the diagonal. So with vertical angles, angle 1 would be congruent to angle 2, and then angle 3 would be congruent to angle 4, which I'll get more into that in a minute. There is a theorem about that, but when you do vertical angles, it's the one directly across from it, so, or diagonal from it. So angle 1 is congruent to angle 2. Angle 3 would be congruent to angle 4. Those are the opposite angles are considered vertical angles. Now, I have a very short theorem here. I have 2 proofs, and then I have a couple of exercises with vertical angles. Okay, so here is another theorem for you, which I'm just going to abbreviate it THM. This is very short too. I'm just going to abbreviate it like this. Vertical angles are congruent. Okay, so the theorem is that vertical angles are congruent. Well, that was pretty short and sweet. That's an easy theorem. We are going to use this theorem all the time throughout geometry. From here on out, you will use this all the time. So I would commit this to memory if I were you. Vertical angles are congruent. Okay, I think that was a simple enough one. Let me draw now a diagram here. Okay, let's see how it's worded. Nope, didn't want to do that. So, here I have a diagram of vertical angles with angles 1, 2, and 3. Now this is going to be a minor proof. Given. So what we've been given here, it tells us that angles 1 and angle 2 are vertical angles. So angle 1 and angle 2 are vertical angles. They tell us that. Okay, now what we have to prove, so we are going to prove this theorem, is that angle 1 is congruent to angle 2. So that's our proof for this problem. We're given that angle 1 and angle 2 are vertical angles. We got to prove that angle 1 equals angle 2. All right. Now, this is going to be a unique proof. I'll explain in a minute here. Whoops, why am I drawing a line? I don't need the arrows. What am I doing? I need to just draw columns. I need to draw 2 columns for the proofs. Okay. So of course we have the statements on the left. we have the reasons on the right. Now, the thing about proofs in geometry is there's technically no certain way to do them. It's one of those you have to be the judge of how to do it. Now, the examples I've shown you give you that between the previous lessons and what I'm about to show you today give you a general framework, but really when you do it, this isn't like algebra where you have a problem, here's the method you're supposed to use, solve the problem with this method. No, proofs you have a lot more leeway, a lot more freedom. Now, we have here angle 1 and angle 2 are vertical angles. We want to prove that angle 1 is congruent to angle 2. If you look at the diagram here, wouldn't it be true that the measure of angle 1 plus the measure of angle 3 equals 180? Right? Because you have a straight line going through here. That would mean angle 1 and angle 3 are supplementary angles. And then likewise, you have angle 3 and angle 2. You have a line going through here. Measure of angle 3 and the measure of angle 2 equal 180. This is a case, a rare case, mind you, where you're not going to use the given information at all. In fact, there's no rule saying you have to use the given information. In general, you want to, it's good, but in this case, it's actually not going to help you. So let's go ahead here. Reason 1. We see a straight line. We can say that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. And then likewise, on the same line, we can say the measure of angle 2 plus the measure of angle 3 equals 180 degrees. We can combine this into one statement. What is that going to be? Well, this is going to be by the definition of supplementary angles. Right? Because we can clearly see if you add 1 and 3, you get 180 degrees. If you add 2 and 3, you also get 180 degrees. It's clear to see you got two straight lines with those, so they're supplementary angles. Here's where it gets interesting. Step 2, it's true that 180 degrees equals 180 degrees. That statement's true by the reflexive property. So by the reflexive property, 180 degrees equals 180 degrees. Which means now, since we have 180 degrees equal to 180 degrees, for each of these 180s, we can substitute the equations in. So step 3 is going to allow us to substitute the measure of angle 1 plus the measure of angle 2. Whoops, I'm sorry, I was wrong there. Measure of angle 1 plus the measure of angle 3 would be equal to the measure of angle 2 plus the measure of angle 3. We can say that by the substitution property. Okay. And then last but not least, doesn't each side of the equation have a common measure of angle 3? That means we can subtract that out. And if you do that, you'll get the measure of angle 1 equals the measure of angle 2, or angle 1 is congruent to angle 2. They mean the same thing by the subtraction property. So we ended up proving this by good old subtraction. So this is a rare example of not using given information. Now, it turns out it's true that angles 1 and 2 are vertical angles. That's great, but we technically I mean, I guess we needed it for the theorem's sake, but we didn't actually have to put that in. But we started with the measure of angle 1 plus the measure of angle 3 equals 180 degrees, and same with the measure of angle 2 plus the measure of angle 3 being equal to 180 degrees by the definition of supplementary angles. Then 180 degrees equals 180 degrees by the reflexive property. And then by using substitution for each of these 180s, we got the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3 by the substitution property. And then by the subtraction property, we come up with the measure of angle 1 equals the measure of angle 2, or angle 1 is congruent to angle 2. So we have now just proven vertical angles are congruent. So from here on out, you are free to use this theorem in any other proofs. So any other proofs come up, this is now a valid theorem you can use since you've already proven it. So I have another proof which actually is not going to be quite as bad as this one. You're going to see it's not going to be nearly as bad at all. Alright. I would like to do, let's see here. Let's draw a nice triangle. Excuse me, with a line going through here. We're going to set up a triangle, okay? I have angle 1 here, angle 2 here, angle 3 here, angle 4 here. So I have a triangle with a line that's the base. I have angle 1 here, angle 2 here, angle 3 here, angle 4 here. So now we got to do a proof. So we've been given that angle 2 is congruent to angle 3. So we're given angle 2 is congruent to angle 3. What we're being asked to prove now, we have to prove that angle 1 is congruent to angle 4. So we're given that angle 2 is congruent to angle 3. We need to prove that angle 1 is congruent to angle 4. That's not so bad. Let's set this problem up again here. Do our 2 columns. Okay. Nope, didn't want to do that. Alright, let's see. Statements on the left, reasons on the right. Okay, in this case, I would start with your given information. Let's see, so we have angle 2 is congruent to angle 3 as our first statement. Well, that's given, so that's our reason. That was given to us. Now, we can say that angle 1 is congruent to angle 2, and then we can also say that angle 3 is congruent to angle 4. Why can we say that? By that good old theorem we just proved that vertical angles are congruent. So by vertical angles are congruent, we can say angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 4. Those are vertical angles. Now, we can immediately jump right to our proof. We can say angle 1 is congruent to angle 4. How, you might ask? We could break this up into 2 separate steps, but you'll be listing the same reason twice. Alright, so if angle 1 is congruent to angle 2, right? Which means angle 2 is congruent to angle 3. By the transitive property, that means angle 1 is congruent to angle 3. So if angle 1 is congruent to angle 3 is congruent to angle 4, that means angle 1 is congruent to angle 4 by the transitive property used yet again. So by the transitive property, if you use it more than once, you'll say how many times. You'll say use 2 times or use twice. So angle 1 is congruent to angle 4 by the transitive property use twice. So this was a nice 3-step proof. It actually didn't take that long. Some of these aren't that bad. Okay. I thought that was a fun little proof, actually. I thought it was kind of nice. Easy one. Not all proofs are bad. Not all are hard. Okay. How many exercises? All right, I have here 5 more exercises. These aren't going to be bad at all. These actually will not be bad at all. I'll make it nice and big so you can see clearly. So let's see. This angle here is equal to 3x minus 5 degrees. This angle down here is equal to 70 degrees, okay? We have 2 vertical angles here. We have 3x minus 5 degrees for the top part, 70 degrees for the bottom part. If we remember, vertical angles are congruent. So here's where algebra comes into play in geometry. If these 2 angles are congruent, all you need to do now is simply set one angle equal to the other. So you'll set 3x minus 5 equal to 70. We're going to solve for x, which means 3x equals 75, which simply means that x equals 25. So by doing that, we found the value of x to be 25. So yes, this is where algebra does come into geometry. Alright, I'm going to keep this similar drawing here. I have 4 more exercises. I think I'll write this one in blue. I should have done that from the start. This one here is going to be 3x plus 8 degrees. This one down here is going to be 6x. Here, let's do this. 6x minus 22 degrees. So we have 2 vertical angles. One is equal to 3x plus 8 degrees. The next one is equal to 6x minus 22 degrees. Well, again, vertical angles are congruent, so just set one equal to the other. 3x plus 8 equals 6x minus 22. Now, we just want to solve for x, so we have 3x plus 8 equals 6x minus 22, which would give us negative 3x plus 8 equals negative, well, why did I write 88? That's going to change my answer big time. Just 8 is equal to negative 22, which means negative 3x would equal negative 30, which simply means x would equal 10. So the value of x from these 2 vertical angles would be 10. So yes, now you're starting to fully see where algebra and geometry come into play together. Okay. Still a nice straight line. And then we have, running through here, Alright, so this is a little bit different. They give us for this angle here, this arc denotes an angle that the entire thing is equal to 4x degrees. This entire thing is equal to 4x degrees. Now, this angle here equals 64 degrees. This angle here equals 36 degrees. So, we need to find the value of 4x, or ultimately the value of x. Take a look at this diagram here, right? The vertical angle for 4x, if you pretty much erase this ray, would be the 64 and 36 added together, right? So we know that 64 degrees plus 36 degrees equals 100 degrees, right? Now it's easy. You just take the 4x, you'll set it equal to 100, which means x would give you a value of 25. So, then if you plug this in here, 4 times 25, that would give you 100 degrees. 64 and 36 also gives you 100 degrees. So, that's where sometimes with vertical angles, they do try to trick you. Alright, I just have 2 problems left here. This is going to be different yet. We got some differences here. Okay. Looks like just 2 lines. So let me come down here a bit so you can see better. And then I believe this is what happens here. Alright. What have we got here? So we got this angle equaling x degrees. We have this angle equaling 3x minus 8 degrees. Now here's where it gets fun. We have this angle being 2y minus 17 degrees. All of a sudden we have 2 variables. 2y minus 17 degrees for this angle. Well, it's obvious based on this diagram that 2y minus 17 would equal 3x minus 8. But we got to find the value of both x and y, do we not? Here's what you're going to do, because some people would think, oh, that's a system of equations. No, it's not, actually. It's not a system of equations at all. In this case, what you would want to do first, I would recommend solve for your x. We know the straight line here, well, that's just what it is, a straight line. If we add x and 3x minus 8, we'll get the sum being 180. So go ahead and take your x plus your 3x minus 8, set that equal to 180 degrees, okay? Now, x plus 3x, well, that's 4x. Negative 8, so you add 8 to both sides, that would equal 188. So 4x equals 188. Which, God forgive me, I don't remember what that is. I'm just going to use a calculator real quick. 188 divided by 4 is 47. So it looks like x would equal 47. Alright, great. So we've solved for x, now we need to solve for y. So you got your x value, but here's the thing. This 2y minus 17 angle, the vertical angle to that is 3x minus 8. So what we actually need to do is put in that 47 in the 3x minus 8. So you'll take 3 times 47 minus 8, which, let me see what that is. 3 times 47 is 141 minus 8. 141 minus 8, that's going to be 133. So this angle here we can say equals 133 degrees. Okay. So now we found the vertical angle to 2y minus 17. Last but not least, you're going to set 2y minus 17 equal to 133, which simply means 2y equals 150, which means that y equals 75. So those are your values for x and y. X would equal 47, y equals 75. Then I do have one more. I do got one more for you. This is another two variable one, so I think everyone's pretty good with one variable, but the two variable ones can get a little hairy sometimes. So let me set this up again here. Basically, we're going to do this number. So let's do this. Almost looks like a coordinate plane, but we're not drawing a coordinate plane. Okay, so let's do that. This one equals x degrees. This one here is, let's see, what was that? 2x minus 16 degrees. And then this angle here is 50 degrees. This particular angle here is 3x minus y degrees. So that's where the second variable comes into play, all right? So we have four angles, well, two pairs of vertical angles. We have x, which the vertical angle to that is going to be 3x minus y. Well, we're not going to be able to solve for either x or y if we do that. You technically could do a system of equations for this one. I'll tell you why. Because 2x minus 16, the vertical angle to that is 50. You could set that equal to 50, set x equal to 3x minus y, but honestly, I don't suggest it. So it's going to be just as long to do it the way we're going to do it. So let's start here. I would take your 2x minus 16, set that equal to 50. Let's solve for x first. So take your 2x minus 16, we will set that equal to 50, which means 2x would equal 66, which means simply that x equals 33. All right, so we found the value of x. Now let's find the value of y. It's clear that x and then 3x minus y are vertical angles. So that means 33 is going to equal 3 times 33 minus y, which means 33 equals 99 minus y, which means that negative y would equal negative 66, so then y would have to equal positive 66. So the value you're going to find from y in this particular equation is 66. So that's it for the vertical angles. That's it for this lesson. The next lesson, we are going to get into perpendicular lines. We will have 3 theorems about those. So I hope everybody has a good night. Take care.